Today, we're going to spend some time talking about inverse functions, and particularly inverse trig functions. So before we do that, I want to just think about some functions that we know really well. First one is y equals x squared, which I'm just going to go ahead and sketch that. So here it is, this parabola. I'm ignoring this for the moment. And then its inverse, we know that the inverse of squaring is square rooting. So the inverse function is square root. So that looks like this. Okay. Now, we know from last semester that inverse functions always reflect across the line y equals x. And we do see this happening. However, if you were to reflect this parabola completely, it would look like this. But notice that this is not a function because it doesn't pass the vertical line test. So in order for it to pass the vertical line test, we can't have this part of the graph. Okay. Now, these aren't real reflections of each other unless we restrict this one. And so that's why we had this restriction. Okay, so if you have the function y equals x squared for only values greater than or equal to 0, then it does have an inverse function, which is the square root. So we learned last semester that a function only has an inverse if it passes the horizontal line test. Because remember, the inverse needs to be a function. The inverse needs to pass the vertical line test. So that means the original function has to pass the horizontal line test. It can only hit once. And that's why we had to restrict this. Okay, so we're going to apply the same idea to our trig functions. And we will need to use some restrictions in order to make this work. So if we're talking about sine, we're going to focus on sine first. It doesn't have an inverse, okay, because it does not pass the horizontal line test, okay? If I do a horizontal line, notice I'm hitting like a million times. But we can restrict this so that it does have an inverse. So what we want to do is take the biggest section that does pass the horizontal line test. So we're going to take from here to here. That's the biggest section of the sine graph that passes the horizontal line test. And so that's from negative pi over 2 to pi over 2, okay? So if we restrict, we can take the inverse sine. You are used to taking the inverse sine. The button on your calculator looks like this. It looks like sine to the negative 1. It's not. It's inverse sine. And it's right above the sine key. Now, we are more and more going to use this notation, arc sine. These mean the same thing, arc sine and inverse sine. So again, your calculator uses this notation. When we get through calculus and stuff, we're going to be tending more towards this notation. So just know arc sine, inverse sine, same thing. So when we're finding the inverse, it's finding the angle that gives us a particular value. Okay, so we are looking for the angle. So when we do these, remember that we have to restrict our domain. So our answers have to be between negative pi over 2 and pi over 2. So when we're looking at this, when we go to draw this between negative pi over 2 and pi over 2, that's either the first or the fourth quadrant. So when I draw the triangles, I want to make sure I'm drawing them in the correct quadrant. So the first one, we want to find the arc sine of 1, the inverse sine of 1. So what we're doing is we're looking for the angle whose sine is 1. Now, since this is positive, I'm going to draw it in the first quadrant. And sine is opposite over hypotenuse, so 1 and 1. And if we do the Pythagorean theorem, we can see that this side is 0. So this is a really terrible picture. Okay, what's happened is these two sides of the triangle are the same, and they're both 1. And then this side down here is 0. So what's happened is this triangle is actually all smashed up right here. Okay, and our answer is pi over 2. So if you put the sine of pi over 2 in your calculator, you will get 1. Let's try another one of these. So we're going to draw a triangle so we can find our exact values. Remember, for sine, it has to be between negative pi over 2 and pi over 2. So it's not going to be in those. But since it's negative, we're going to be down here in the fourth quadrant. So we'll draw a triangle. And we have opposite side is negative 2 and hypotenuse is 1. Now, something should look a little strange about this. The hypotenuse is supposed to be the longest side, and it's not. So that means that this has no solution. Okay, there can't be a triangle that does this. And if you do this in your calculator, if you put in inverse sine of negative 2, it's going to tell you error or no solution or something like that. Okay, let's try and get one that actually has an answer. We want to find the arc sine of -1/2. So we're looking for the angle whose sine is -1/2. Okay, remember we have to be between -π/2 and π/2. And since it's negative, we'll draw our triangle in the fourth quadrant. The opposite side is 1 and the hypotenuse is 2. Well, -1. So using Pythagorean theorem, that's 3. So we can see that this is a 30-degree angle. It's a -30-degree angle. And we want our answers in radians. So -30 degrees is -π/6. And the reason we want them in radians is because that's in radians. All right, one more of these. We want to find the inverse sine of √3/2. So we want to find the angle whose sine is √3/2. Not going to be in those quadrants because we're restricted to -π/2 to π/2. Since it's positive, we're going to be in the first quadrant. The opposite is √3, the hypotenuse is 2, and we recognize that triangle. This is a 60-degree angle, which when we put it in radians is π/3.